Hello everyone, I hope you're doing well. I'm Taha El Ghabi and my colleague Farzattin Patori are so happy and excited to share with you our advanced learning project, which is entitled the Real-Time Video Segmentation Web Platform. So, we're gonna first talk about the idea of the project. We're gonna then move on to the video segmentation part. Then we'll see one of the most interesting aspects of every machine learning project, which is the deployment phase. Then we're gonna finish by a demo in the conclusion. So, where did this project come from? So, my colleague and I thought about the applications of deep learning, and we find out that video segmentation is one of the most interesting ones. But more often than not, we gather some dataset, we create a model, we train it in a Jupyter notebook on our local machine, but it stays there. It never actually sees a real world usage, and nobody actually gets to try it and test it. So what we want to do is create a web application that's going to provide a real-time video segmentation for everyone, that's going to be accessible through the internet and hosted on the cloud. So now we have some technical requirements that we have to put. First of all, our web platform has to be a simple web interface for accessibility, so that anyone can use it simply, and its main goal is detecting faces and eyes. The second point is that our model is gonna have to be efficient and fast, since our application is gonna be run on the client side, and that's a challenge that we will talk about later. It has to be efficient, since the application is a real-time one. The third point is accessibility. Our application has to be accessible from everywhere, which means that we have to deploy it in a cloud platform. So, moving on to the second part of the project is the video segmentation. So, our goal in this part is making a real-time face and eyes detection system. So, the tools and technologies that we used is of course Python, which is the language that is used in all of these packages. We needed Flask since we are trying to make a web application. We choose Flask because it's very light and very efficient. We also choose OpenCV because it is capable of course of showing images and getting stream of a video. And the third thing that we used is Hard Cascade. So Hard Cascade might not be the most sophisticated thing to use, but actually in our use case they are the best, and we're gonna see why. So moving on, why did we choose Hard Cascade and not the most sophisticated TensorFlow, CNN or something? Simply put, our application is gonna be run on the client devices, and the client devices are not that powerful. So we have to make a fast and a model that is light for client devices. The second point is that Hard Cascade are easy to use and are widely implemented in a lot of clients' applications. So the third point is Hard Cascade provide you with a real-time detection of multiple objects at once, and it is very easy to do. You don't have to make some adjustment or anything. The fourth point that is an advantage to Hard Cascade is that they can be trained and can be turned down to your own preferences and use case. So they provide both a fast, light performance as well as the flexibility if you want to change something. So now we can see here the first, let's say, prototype that we had. This is the Hard Cascade and OpenCV working together to detect my face here and my two eyes, one by one, and drawing a rectangle around them. So now we did the first step, which is making a demo that's working locally on the machine. So now the second part is making the web application. So we created a simple Flask application in which we used OpenCV to get the video capture, and we created some endpoints that will display the output of the processing in our template of the Flask server. So it's very simple. As you can see here, it is on localhost port 5000. You can see here real-time face and eyes detection, very simple stuff. You can see the GET request when you enter the URL and get to this page. And as the previous example, it's nothing fancy, it's doing its job. Now the problem is, how can we host this application on a cloud platform? You might say that, yeah, you can just follow some tutorial of Flask deployment on Google Cloud or Heroku, and it's gonna be easy. But it's not, because the problem that we have here is this camera that we have, the input of the video stream that we get is coming from the backend. And when you access a website, you are in the client side. You cannot access the backend. So this has become a very big challenge for us in our project. So we thought about multiple solutions, and what we came up with is gonna be seen in the third part, which is the deployment and development process. So in this part, we're gonna see how we were able to came up with an architecture and host it on the cloud. So the main architecture of our project is as follows. We have the user here who have a video streaming device, a camera of course, is gonna just send simply that video stream to the client side, which is a very simple thing to do, nothing complicated, with JavaScript of course, our client side. When the client side is gonna have the video stream, we're gonna use socket.io, which is a Python and JavaScript package. It is used on multiple languages of course. It's gonna send the video stream from the client side to the server. Our server here is a simple Python unicorn server, and once the server is gonna get that video stream, it's gonna pre-process it of course, then send it to our model API that is hosted on Google Cloud Run container. Once the model is gonna give the prediction, sort of say, it's gonna send it back to the server. Server is gonna send it to the client side through socket.io to see the video, the processed video in the client side for the user. So this is simply how it's gonna go. So now we're gonna see the CI/CD pipeline. So as you might notice here, we'll have a lot of languages, a lot of files, multiple projects, mini projects separated. So in order to deploy them, we'll have each time to write the code or changes that we want, commit them to GitHub, and push of course to the repo that we want. Then in case of the model, we're gonna have to build a Docker image, test that Docker image locally, upload it to Google Cloud, then deploy it, which is a very long process of course. Same for the client side, same for everything. So it's gonna be a very long process, which cannot be done conveniently. So what we thought about is one of the most important practices of software development, and that data scientists often neglect, but it's very important, which is continuous integration and continuous deployment pipeline. So we created a pipeline using Google Cloud Triggers, and this pipeline, what we'll have to do is just write the code that we want or changes, just push them to the repo, and from here and on, everything is gonna be automated. The build is gonna be auto built with the Google Cloud Platform build triggers. The testing is gonna be also be done by Google Cloud. Then once the application is tested, the production phase is gonna be automatically done via Google Cloud to the public, so that everyone is gonna see the latest changes of our application. So here is our GitHub repo. As we can see here, we have a lot of files specific to the deployment phase. Docker ignore file, Docker file. We even have a proc file for Heroku. We're gonna talk about it later, and of course requirement.txt, runtime.txt, test.py, and so forth. Now here in Google Cloud Platform, this is our project, video segmentation platform. We can see here that we have linked it with our GitHub repo, and we have specified the event and what happened once once we push to the repo, and also some configurations specific to our project. Now the tool technologies that we used, of course, as I mentioned, we used Heroku at first. Why? Since it is very simple to deploy in. We found it very simple. It's not as complicated as Google Cloud, and of course you don't need to have a credit card to do so. But unfortunately, once we deployed our application on Heroku and accessed it on mobile phones or some low-end machines, the performance of the model was barely acceptable. We could not get a stable video stream in the application. So what we choose to do is go to Google Cloud, since it provides you with some configuration that you can change everything about the container that you have. So the main technologies, of course, is Cloud Build API. Cloud Build is the API that builds the Docker images. We of course had to know some things about Docker, since we are working with containers, of course. Cloud Run is the API that deploy your Docker image to a platform that everyone can access. So here is the technologies that we used for our deployment. Now, as we can see here, here is our application, our D-log of our application on Heroku. Some post requests, get requests, and of course socket.io, since we are using socket to communicate between the backend and client side. As we can see here, here is the demo of the mobile app provided by Heroku. The problem with this platform is that it does not detect completely my eyes. It just detects my face, which is a byproduct of not being able to choose the exact performance of our container. But in contrast, in Google Cloud, as we can see here, you have a lot of options to choose from. You can change the memory, you can change the number of CPUs that you have, you can change the maximum request, and most importantly, you can allocate your CPU to be always on, so you won't have to deal with a very long loading time for the first time. Okay, and not only that, but Google Cloud also provide you with a very sophisticated dashboard in which you can see the request count, the request latencies, the container CPU utilization, and so forth. It is very detailed description of your container. So now we're gonna move on to the fourth act of this presentation, which is the demo and the conclusion. Okay, so here is the final platform that we have created. As we can see, we have a beautiful background that suits the theme of the presentation. We have a real-time video segmentation platform. As we can see here, we have the client video stream and the socket IO processed video, in which you can see the model selecting the face and the eyes. Okay, so we can access our platform either through scanning the QR code or clicking the link below. As you can see, it loads very fast. It is now recognizing my face and my eyes. It is not now perfect because it's a very bad lighting condition, and of course I have a reflection in my glasses. If I remove them, for example, it's gonna be able to recognize my eyes much better. So yeah, this was basically it for our application. Now we move on to the conclusion. So what we have learned from this project is that it is not straightforward to have a application that is working on your local host on your machine and just deploy it. It is not just easy as straightforward as everyone thinks. Some applications that requires you to get something from the client, either an image or video, especially real-time applications, are very hard and can be tricky to do. So we have learned a lot. We have seen how to host on Heroku, how to use Google Cloud. We have seen Socket.io, Cascade, and so many new concepts. So in terms of getting some knowledge, we have learned a lot, and this project was very beneficial. So we thank you so much for this opportunity, and thank you for your attention. Goodbye.